Is there anybody here? Can you guys listen to me? If you can listen to me, please write yes. Okay, fine. Uh, Today we are going to learn about reflection, and in this process, we will experiment with some new learning method which heard. You might have heard about flipped classroom, which usually we cannot employ in our regular classes due to lack of resources. So here, what you will do, you will first go through the tutorial, then within some stipulated amount of time, you have to attempt a quiz. The quiz will have 10 questions, and this quiz will give you an insight of your understanding of the topic. Let me try this today. And during the tutorial, don't forget to write your university roll number into the chat box so that we can keep a record of this live session. So let's start. First, we will start the tutorial. Watch it carefully. I hope all of you have a notebook and pen with you. So whenever you think it is necessary, don't forget to keep notes, right? So let's start. Today we are going to study reflection in 2D. Before diving deeper into the reflection phenomena, first look some of the salient features of reflection which you observe in day-to-day lives. Reflection basically creates mirror images. We all know that by our day-to-day observations. Now let we try to look into this phenomena from geometric point of view. Say this is your two-dimensional space which you usually define in terms of x-axis and y-axis. Now assume that in the first quadrant of the space you have a triangle ABC. Here. Now, can you imagine what will happen if you reflect this triangle ABC with respect to the y-axis? Just think for a few moments and try to figure out the answer. If you reflect this triangle ABC with respect to y-axis, then you will have the reflected image of this triangle into the second quadrant of this 2D space somewhere here, and this is going to be your reflected image. If you carefully observe, the reflected triangle A-B-C- is basically the mirror image of the original triangle. It is the mirror image of the original triangle. And if you follow further, then this distance is equal to this distance. The horizontal distance from point A to the y-axis is equal to the horizontal distance between A dash and y-axis, and the horizontal distance between the point C, let me do it with another color, is equal to the horizontal distance between point C dash and y-axis. So this is a reflection with respect to y-axis, where you get a mirror object of the original thing onto the other side of the y-axis. Now let we do the same reflection thing with respect to x-axis and try to follow what phenomenon occurs here. Again, let we first define our two-dimensional space in terms of x-axis and in terms of y-axis, and let we draw our triangle A, B and C here. And now we will try to do the reflection with respect to x-axis. Reflect triangle ABC with respect to x-axis, and let me try to observe what will follow. If you follow the previous discussion, then you will be able to observe that after reflection, the distance in between point B and the reflection of point B must be equal. So you will have your point B somewhere here. Similarly, for point C, the distance between it and x-axis is going to be equal to the distance between the reflected point and the x-axis. So C dash is going to be somewhere here. Similarly, if you reflect point A with respect to x-axis, the distance between point A and x-axis is going to be the distance between the reflected point of A, which is going to be A dash, and x-axis are going to be equal. This distance and this distance are going to be equal. Now let me join the three reflected points, and if you join the three reflected points, you will get the entire reflected object. In this case also, you can observe that you actually get a mirror image after reflection. So let me now dive deeper into the reflection phenomena. So from the discussion what we have done until now, we can conclude two things. Number one, we get mirror image in reflection. And point two, if you go back to the previous two diagrams, you can see that for both the cases, reflection was performed with respect to some line. For example, in the first case, the reflection was done with respect to y-axis, which essentially is a line. Y-axis itself is a line. Similarly, in the second example, what followed was that the reflection has been performed with respect to x-axis. Once again, x-axis itself is a line. So we can conclude that in two dimensions, reflection is performed with respect to some line. Now in two-dimensional space, x-axis and y-axis are the lines which are always defined by default. However, reflection don't always have to be performed with respect to x-axis and y-axis only. It can be performed with respect to any line. Say this is your line L, and you want to reflect point A with respect to this line L. So just what you can do, you can hold this entire piece of paper by this line L, and if you do this folding, you will get a mirror image of this point A somewhere here. So this is your reflected point of A with respect to this line L. This we will go see later on during this module, but at first let we do some deeper dive into this reflection phenomena. Say this is your x-axis and this is your y-axis, and here is your point xy, which you will reflect now with respect to y-axis. So as we have discussed before, you will get your reflected point somewhere here, x dash y dash. Now if you can observe, x dash is going to be equal to minus x and y dash is going to be equal to y, and this was reflection with respect to y axis, 0 extra 1. Now your equations become x dash equals to minus x, y dash equals to y, 1 equals to 1, and this implies x dash y dash 1 equals to minus 1 0 0 0 minus 0 1 0 0 0 1 multiplied with x, y and 1, and this is your generalized reflection matrix with respect to y axis. Now let us try to do reflection with respect to x-axis. Say you have your point xy somewhere here. Now you want to reflect it with respect to x-axis. So what you do, you calculate the vertical distance from point xy to x-axis, which is basically y, and so the reflected point you will get at a distance equal to y but below y-axis somewhere here, x dash y dash, and this distance is basically minus y in negative y direction. So 1 0 0 minus 1 multiplied with, and if you convert this into matrix form, you get x dash y dash 1 equals to 1 0 0 0 minus 1 0 0 0 1 multiplied with x, y and 1. So this is your reflection matrix with respect to x-axis. So in a nutshell, what happens is that reflection matrix reflection matrix with respect to x-axis goes like 1 0 0 0 minus 1 0 0 0 1, and reflection matrix with respect to y-axis goes like minus 1 0 0 0 1 0 0 0 1. So this was the basic derivation of reflection matrices along x-axis and y-axis. Now let we try to apply this sum towards real problems. Say you have a point 4 2 which you want to reflect with respect to x-axis. What will be the coordinates of resulting point? So just have a look at the problem once again. You have a point 4 2 which you want to reflect with respect to x-axis. What will be the coordinates of resulting point? So as per the problem statement, x is 4 and y is 2. You are being told to reflect this point xy with respect to x-axis. So your reflection matrix will be 1 0 0 0 minus 1 0 0 0 1, and your x dash y dash, that means points after reflection, you can get by multiplying t ref with xy1. So it will go like x dash y dash 1 equals to 1 0 0 0 minus 1 0 0 0 1 multiplied with 4 2 1. So x dash becomes 1 multiplied with 4 plus 0 multiplied with 2 plus 0 multiplied with 1 equals to 4. Y dash is 4 multiplied with 0 minus 1 multiplied with 2 plus 0 multiplied with 1 equals to minus 2. So x dash y dash equals to 4 minus 2. So you are going to get your resulting point at 4 minus 2. So that was all about reflection. So this was the tutorial for reflection in 2D, where we have uh, studied different facets of reflection in 2D. Now what you have to do is you have to attempt one quiz. You have to go to Google Classroom and then find this reflection quiz under the quiz section. I'm assigning it right now. So try to complete this task within 10 minutes. The questions are simple. If you have taken notes and observed the tutorial carefully, you will be surely able to find the answers in a short amount of time. In my clock, I can see that it is 11 and 1. So try to complete this task within 15 minutes. Then we will discuss the answers. This will give you an insight of your understanding of the concepts. Here is the URL. Now is I can see that 11 to time 15 minutes. We will meet, discuss the be honest and try to do it yourselves and try to do them as quickly as possible. Is there anybody who has not done yet? We see that until now we have 10 responses. Well, so 16 responses. Moshihul done. Shalwani done. Okay, it's uh 11:17 now. So now for some time I am stopping accept responses, and you can see a summary of the results here. 10 of, so let's have a look at the solutions. uh, First question goes like, uh, in reflection you get a mirror image. The correct answer is true. If you can recall the first portion of the discussion, you can find that when you reflect an object with respect to a line, in our case the primary axis, you get a mirror image of the object onto the other side of the axis. So answer to the first question is true. Reflection with respect to x-axis is similar to reflection with respect to y-axis if the statement is true or false. Now, this question is very simple. Reflection with respect to x-axis and reflection with respect to y-axis are actually different. When you reflect an object with respect to x-axis, you get your reflected image onto the other side of the x-axis, and when you reflect with respect to y-axis, then you get the resulting object on the other side of the y-axis. Now let me move to the third question. It goes like, reflection in two dimensions is performed with respect to a line. Again, the answer is true. If you have followed the discussion, you can find that always in two dimensions, reflection is performed with respect to some line. The line might be x-axis, the line might be y-axis, or it might be some arbitrary line. You can do reflection with respect to some arbitrary line also, in which case you will get your reflected object onto the other side of the line, where the distance from the point to the line will be equal to the distance from the reflected object to the line. So again the answer is true. Now you reflected the point 1 0 with respect to y-axis. What will be the resulting coordinates? I can see that Shatik is writing down his roll number into the chat box. So as we are near to the end of the session, all of you please follow him, write down your roll number, as well as follow the discussion. Reflection in 2D is performed with respect to a line. Yes, that we have done. You reflected the point 1 0 with respect to y-axis. What will be the resulting coordinates? Now it goes like, you reflected the point 1 0, say it is here, point 1 0, with respect to y-axis. So you will get the reflected point onto the other side of the y-axis somewhere here. Now you can find that the distance from your original point to y-axis will be equal to the distance from y-axis to the reflected object, and this distance is actually -1. So your new coordinate will be -1 and 0. Here, this one. Then let me proceed to the next question. The resulting image from reflection can be achieved by translation. If you give it a thought, you will find that the answer is false. Why? Just go back to our triangle example. This was a triangle which we reflected with respect to y-axis. Now, if you observe from reflection, you actually get a mirror image of the original object. But if you translate this thing, you will get something like this, which is not actually a mirror image. So translation and reflection are not actually same things. The result here is false. The resulting image from reflection can be achieved by rotation. Now, in this case, follow this example. If you reflect this point 1 0 with respect to y-axis, you get your reflected object at -1 0. Now just think for a while, what will happen if you rotate this point 1 0 by an angle of 180 degrees into anti-clockwise direction? You will arrive at the same point. Similarly, if you rotate this triangle by an angle of 90 degree, you will get the reflected image of the triangle. So that makes sense. With reflection, with rotation, actually you can get the same result as that of reflection. So in this case, the answer is true. Now let me move to the next point. It is 11:26. I think Obijit sir is waiting for you, so I should move faster. You reflected point 10 with respect to y-axis. Instead of using reflection, if you want to achieve the same result by rotation, by what degrees uh, you need to rotate the point. Now, this was same as this discussion. You have reflected this point 10 with respect to y-axis and the resulting point is now at minus 10. You can achieve this reflection by rotating this point by an angle of 180 degrees anti-clockwise direction. So your answer is 180 degrees. Now come to the next question. You reflected point 10 with respect to y-axis. Instead of using reflection, if you want to achieve the same result with rotation, by what degrees you need to rotate the point. So now what happens, you see your uh, point is at 0, 1. That means somewhere here. Now you have to reflect it with respect to x-axis. So your reflected point will be somewhere here. You can see that if you rotate this point by an angle of 180 degrees in clockwise direction, you will get the same result. That means your angle of rotation now becomes minus 180 degrees in clockwise direction. In clockwise direction, the angle becomes negative. Now let me move to the next question. What will be the resulting coordinates of the point if you reflect point 14 with respect to y-axis? So, x-axis. What will be the resulting coordinates of the point if you reflect point 14 with respect to x-axis? You have a point 14 somewhere here. Now, if you reflect it with respect to x-axis, your reflected point will be here. That means its coordinate will now become 1 minus 4. You have moved to the negative y direction. So, correct answer is this one. Last question, you reflected point 10 with respect to x-axis. What is the resulting point? You reflected point 10, 10. Your point 10 is here. So if you reflect it with respect to x-axis, you can find that the resulting point will lie onto the x-axis itself. So the correct result in this case is 10. So hope you have learned something and you have got some idea how flipped classroom works. So give it your time, watch the video later on if you think it is necessary. Have a good day. Now I am disconnecting and go to the West class.